Hello everyone, welcome to ExamRat. My name is Shatabdi, I'm a second year medical student. So our topic of discussion today will be electric current. Okay. So what do you mean by current? So we have listened to this term since we were kids. We always know that current is something that flows through wires and how we should not touch a socket which is already switched on, right? So current is both flowing through the wires that we can see and also through the wires that we cannot see, which end up in sockets, and these sockets also contain current in them. So what we put here is that we put plugs here, right? So this is all that we have known growing up about currents. Okay. So now we are going to talk about how it is defined in physics. Like what does it exactly mean? Like this flow of current that is happening, the reason why we are talking right now, like the reason why there's a computer in front of me and it is on, and the reason why we have ACs, fans, everything, all electrical appliances, like what is the basis of it. So today we are going to go till the crux of it. So what is an electric current? It is expressed by the amount of charge flowing through a particular area in unit time. Okay. So charge flowing through an area per unit time. Now we know all the atomic particles which have charge, right? We know proton, which has a positive charge. We know neutron, which has a negative charge. We know electrons, which have a negative charge, and a neutron which has no charge. It is neutral. Okay. So this when we have talked about atoms, we've gotten to know about this concept of charge, right? And this charge has somehow led to current. Now what is the direct relationship we are going to understand now? So for starters, it is given that current is nothing but, okay, so current is represented by the letter I, so let's just go with that. Current is basically charge flowing through a particular area per unit time. Q by T, charge is represented by Q and per unit time. Okay, so amount of charge, how do we calculate? Like, we have till now known that protons have positive charge and electrons have negative charge, but what is the amount of that charge? What is the quantity of that charge? So basically, we know that one electron carries a charge of 1.6 into 10 to the power minus 19 coulomb. So by now we know that coulomb is the unit of charge. Like second is the unit or SI unit of time. In the same way, coulomb is the unit of charge. Okay. So now since we know that one electron has this much charge, so now we can somehow calculate that Q is basically Ne. So N is the number of electrons and E is the charge of an electron, which is nothing but this. So now I'm sure you'll understand that when I say amount of charge flowing through a particular area, it is basically nothing but the amount of electrons, or the total number of electrons, which will give us a total amount of charge by multiplying it with the charge of one electron, which is 1.6 into 10 to the power 19 coulomb. Okay. So that is what is given here, is that the SI unit is coulomb, which is equivalent to the charge contained in nearly 6 to the power 80 electrons. We know that an electron possesses a negative charge of 1.6 into 10 to the power minus 19 coulomb. Okay. So basically nothing. Basically what they are trying to tell us is that since I told you that one electron possesses 1.6 into 10 to the power minus 19 coulomb. So they have by unitary method found out that how many electrons contain 1 coulomb of charge. So 1 coulomb is basically nothing but 1 by 1.6 into 10 to the power minus 19, right? These are the number of electrons carrying 1 coulomb of charge, which comes to 6 into 10 to the power 18 electrons. Okay. So this is how we define the SI unit of electric charge, which is coulomb. Okay. So the electric current is expressed by a unit called ampere. So before going further into this discussion, what we have to know here is that we know that electrons are negatively charged. So obviously we know since opposite charges attract, so anything negative will always try to flow towards a positive terminal, right? So the flow of electrons, as you can understand, is happening from the negative pole to the positive pole. Let's say that there's a battery and you know the battery has a positive pole and a negative pole. So the electrons flowing is obviously from the negative pole to the positive pole, because electrons are negative and they will obviously flow towards its opposite pole because opposites attract, and here they'll flow towards the positive pole. Does that mean that the current is also flowing through this direction? No. Conventionally, in an electric circuit, the direction of electric current is taken as opposite to the direction of the flow of electrons, which are negative charges. So what can we say is that the flow of current is like this, from always from positive to the negative terminal. Conventionally, it is taken opposite to the flow of the flow of the electrons, that is from negative to the positive side. Okay. So we've talked about Coulomb. We know now that current can be expressed as Q by T or by NE by T. Okay. So the SI unit again is ampere here, named after a French scientist. 1 ampere is constituted by the flow of 1 coulomb of charge per second. That is this one. Okay. Small quantities can also be calculated, as milliampere. So this is nothing but milliampere, you know, is 10 to the power minus 3 ampere. Okay. An instrument called ammeter measures electric current in a circuit, like how much current is flowing through it is measured by this device called ampere. Just for your information, this sort of diagram is known as a circuit diagram. Okay. It is always connected in series. What is series and what is parallel we'll talk about in the next session, but just for now remember that ammeters are always connected in the series through which the current is to be measured. Okay, so if this is the circuit, then the ammeter is placed in series with it, like connected to any random point. Okay. Now we talk about another interesting concept that is going to make us understand more about the flow of electric current. Like why do we say particularly that current is flowing from positive to negative, and how do we know that always electrons have to travel from negative to positive? For that, we have to talk about potential. So whenever you hear the word potential, the first thing that comes to your mind is potential means the drive to do something. Like if I say that this person has a potential to work hard, it means that it has the ability, the person has a lot of ability to do it, right? In the same way, potential can be considered in physics as something like that. For us to be able to understand it better, it is basically, so giving you an example from not this chapter but from the previous chapters that we had studied about work, power, energy. In case you've missed the videos, you can easily just go to our YouTube channel and watch it. They're all for free. So what used to happen is that when we used to calculate the potential energy, we used to take something at a height, right, and calculate the energy that was stored in that substance with relative to its height, which came as mgh, right? And we know that when you are throwing something from that particular height, the potential energy is getting converted to kinetic energy. At the same time, its height is also decreasing, right? So here it was at a height, and now slowly it is coming towards the ground. So its height is decreasing at the same time. So basically, the concept of electrical potential is that when there is a high amount of, when a point has a high potential, current will flow out of it. Okay, so you know that anything, like whether it is diffusion, whether it is osmosis, or whether it is the pressure difference, things always flow from higher concentration to lower concentration, high to low. Whether it is pressure, whether it is concentration of substances, everything will always move in the direction of higher potential to lower potential. So now it has been said that the positive terminal has a higher potential than the negative terminal. Okay, so now you can understand that if something has a higher potential and something has a lower potential, then everything will always flow from the higher potential to the lower potential, right? So due to the presence of positive charges here, or due to the fact that it is a positive terminal, it has high potential. So current will always flow from high potential to low potential. And at the same time, we can understand now that the negative charges are flowing obviously towards the positive terminal. Because why? Because here the negative charges are more, and here obviously the negative charges are less. So at the same time, negative charges will flow from the negative to the positive terminal. So what we have to remember is that current flow from higher potential to lower. Okay. So now coming to the definition of it, electrical potential difference. Okay, so what is electrical potential difference? So if I tell you that this is point A, this is point B, and A is at a higher potential and B is at a lower potential. Okay, so current will obviously flow from A to B, right? So why? Because there is a potential difference. There is a difference or in potential, because if the potential of A and B would have been the same, then there would have been no flow of current. So flowing of current will always be due to a potential difference. We basically assign potential by the letter V, and why we do that is because its SI unit is also volt. So that is why assigning it by V is easier for us. So basically current is flowing due to the potential difference between 2 points, VA minus VB in this case. So we define electrical potential between 2 points in an electric circuit carrying some current as the work done to move a unit charge from one point to another. So the work that you are doing, or the energy that you are spending in moving one charge, one unit charge, in this case one unit positive charge, from higher potential to lower potential, from one point to another, is the electrical potential difference. Why I'm specifically saying positive charge is because you have to do some work to get a positive charge from the positive terminal to the negative terminal, right? So that is why we are taking it as positive charge only, because if we had taken negative charge, then the concept is getting a bit cumbersome, because we know that negative charge flawlessly does move always from the negative terminal to the positive terminal. Like that is the whole basis of the current. So here that is why we are, when defining, we are saying that electrical potential difference is the work done to move a unit charge from one point to another. So this is the representation W by Q. The potential difference is measured by an instrument called voltmeter. The voltmeter is always connected in parallel across the points between which the potential difference has to be measured. So this is A, this is B. Let this be a circuit in itself. So for now, what you have to understand is that the voltmeter is placed something like this, unlike the ammeter, which was placed like this, like inside the circuit itself. It is placed a bit outside but connecting the 2 points. The main difference you'll understand between the parallel circuit and the series circuit in the next class, but just for till then, remember this. So now the SI unit of electrical potential is volt, as we discussed earlier, and so the SI unit of electrical potential difference is volt, like we discussed earlier. 1 volt is the potential difference between 2 points in a current carrying conductor when 1 joule of work is done to move a charge of 1 coulomb. So it is a no-brainer. 1 volt equals to 1 joule by 1 coulomb. Simple. Okay. So now, since we in our previous slides I had shown you the circuit diagram, so here you have to understand some things. That is, this portion is known as the cell. Like we represent a battery by this symbol. Okay, we represent the ammeter by this symbol. We represent the resistance by this symbol. Okay, it will be very clear when you see these things in the chart. So an electric cell, you know that a number of cells make up a battery, right? So one normal simple cell is represented like this. So the bigger bar is known as the positive terminal and the shorter one is the negative. A combination of cell becomes a battery represented like this. Plug key or the switch, when it is in the open position, open means no current is flowing through it, or you can say the switch is in the off position. At that point it will look like this. Whenever you're saying that in this circuit the switch is on or the key is closed, that means you are completing the circuit. If a key is open, it means that there is no flow of current, right? Because you're blocking the flow. There is nothing here to connect this point to this point. So the circuit has been broken. There is no current. When you are telling me that the key is closed, then it will seem like the current is moving. The circuit is completed. Another way to represent this is it's like this. This is an open key and this is a closed key or a closed switch in the same way. A wire joint is not important in our class. Wires crossing without joining, this you can represent like this. Electric bulb is represented like this. This one isn't because this is like a proper diagram. Resistance or resistor is what we are going to discuss later. For now, just understand the symbol. Variable resistance or rheostat, it is basically a device which basically has a lot of different resistances. So you press a button and that particular resistance comes into action in the circuit. Ammeter to measure current, voltmeter to measure the potential difference. So for now, all these things are only important. Now we come to Ohm's law. So in the previous diagram, like when we were talking about the chart, I told you something about a resistance, right? So now we are going to talk about what it actually is. So it was observed that the potential difference between 2 points is directly proportional to the current flowing through it. What does it mean? It means that more the potential difference, more will be the current flowing through it. Okay. More the potential difference, when I say VA minus VB, the difference is increasing. It means what? It means obviously the potential at VA is increasing, obviously. So if it was 7 minus 5, now it is 8 minus 5. Then it can be 9 minus 5. It is obviously not VB increasing, right? So potential difference increasing means in a way that the electron potential at the higher point, its magnitude is increasing. Okay, so the more you increase the difference or the more you increase the potential at the point A, the more will be the current flowing through it. So since this is a directly, it's like a proportional thing. So to change it into an equation, what should we do? We will provide a constant. This constant is R, which is the resistance. This is called the resistance. So basically, Ohm's law states this only, that the potential difference V across the ends of a given metallic wire. Why is it necessary to be a metallic wire? Because metals are the best conductors of electricity. So the potential difference V across the ends of a metallic wire in an electric circuit is directly proportional to the current flowing through it, provided its temperature remains the same. So temperature cannot increase. Once temperature fluctuates or increase, Ohm's law will not be followed. So as long as the temperature in the metallic wire remains same, the potential difference between a wire, between the ends of a metallic wire, is directly proportional to the current flowing through it. Okay, so this is the thing. Okay, so before going on the factors, since you know that it is a proportionate proportionate statement, so I think by now you know how to represent two things which are proportional to each other in the form of a graph. It's nothing but a straight slanting line, and this is the V, this is the I. So what will be the slope here? How do you calculate the slope? Slope is nothing but just dividing the two components V by I. So what is the slope here? It is nothing but R, right? So now we can understand how R equals to V by I, right? So now R is equals to V by I. Okay. So in other ways, what we can say is that if you say that I am keeping the potential difference constant, like if this acts as a constant, then you can also say that R is inversely proportional to current. So basically now I think you are getting an idea of what resistance is. Resistance, or the word resistant, means something that resists or opposes a motion or opposes something. In the same way that we talked about friction when we talked about the laws of motion, it says that friction is anything that opposes the motion, right? Motion of the actual motion of the object. If the ball is moving in this way, then the ground is providing a friction in the opposite way. It's a resistive force. In the same way, the force that provides a resistance to current, to the flow of current in the metallic wire, is called resistance. So this you can understand now. Now when we talk about the factors on which resistance of a conductor depends, it will be easier for you to understand because it depends on its length, on its area of cross section, and the nature. Okay, so tell me something. If this is a wire and this is another wire, both have the same length. Even if it is not looking in the picture, let's assume both have the same length. But this has a wider area of cross section, right? A, and this has a very small area of cross section. So tell me something, in which of the wires, one or two, the flow of current will be more? By flow of current, in another way, we can also say that the flow of electrons will be the more. Which wire will accommodate more electrons per unit time? This one or this one? Obviously the first one, right? So more the area, more will be the current flowing, and more will be the current flowing, lesser will be the resistance. Why? Because keeping the voltage constant, R is inversely proportional to I. So more the area of cross section of the wire, lesser will be the resistance. So one relation we have gotten, and that is R is, or what we can say is I is directly proportional to A, so R is inversely proportional to A, right? Since more amount of current is flowing through this whole fat wire, so obviously the resistance will be lesser. Here there is less amount of electrons flowing, right? So here its resistance is more. In another way I can tell you is that what happens if I stretch this wire. If I stretch this same wire into a very thin wire, then what is happening, that per unit time the electron flow will decrease, right? As a result of which, what will happen? The resistance will increase and the current flowing through it per unit time will decrease. So at the same time we got another relation, and that is that R is directly proportional to L. More the length of the wire, more will be the resistance of the wire, lesser amount of current will flow through it per unit time. Okay, so R is inversely proportional to A, R is directly proportional to L. We combine these two, what do we get? We get R is directly proportional to L by A. We formulate this into an equation, R equals to rho L by A. What is rho? Rho basically stands for resistivity. Rho is resistivity. It is a characteristic property of a material. So every metallic wire, be it made of steel, made of any alloy, their rhos will be different. Okay, so rho is a characteristic property of a particular metal or a particular material. So R equals to rho L by A. So now we can understand what it said, that resistance of a conductor depends on its length, on its area, and on the nature of its material. And this is the third one, is determined by its resistivity or rho. Okay. Precise measurements have shown that the resistance of a uniform metallic wire is directly proportional to its length and inversely proportional to the area of cross section, what I said. So now, one thing that I forgot to mention is that the resistance, like the SI unit of resistance, is ohm, and it is denoted by this symbol. So the funny thing is that when we find out the unit of resistivity, we call it as mho. Okay, which is actually the opposite of ohm. So that is like this we denote it. So yeah. So resistivity is basically rho. Okay. So conductivity is 1 by rho. Okay. So these are some things that you have to know about it, about this whole segment of it. And in the next session, we will continue with current. So thank you for watching, and we'll meet in the next session.